Okay, good morning, everybody. Good morning. Everybody awake? Let's try to keep it that way. So I want to talk about 7 deployment sins or things that might go wrong in your projects. Who am I? And I lost one screen there, but maybe it will recover. Who am I? I'm Philipp. I work for Elastic, the company behind Elasticsearch, Logstash, Kibana, Beats, the Elastic Stack. But I don't want to talk about our products today. I'm more here to show you what not to do. So first off, do we have any confessions? Since this will all be styled in 7, does anybody have anything to confess before we start? You're doing something wrong. You know that you're doing something wrong, but you don't really know what it is. If not, we'll come back to that at the end. No worries. So this is one of the things that we have in our company. The answer is always, it depends. And this talk is unlike a lot of others where people tell you, you should do this, and microservices are the best, and my framework is the best, and you should totally do that. This is kind of the opposite, where I'm always like, are we really doing the right thing? What are the trade-offs? There is no final answer. It depends. So if you're looking for the talk to say like, oh, I've got the perfect solution for all my problems, this is not the talk for you. I'm more about taking like a step back and thinking like, are we really doing the right thing? And are we going the right direction? And what are we maybe not doing right? So let's see where we can take this. To put it in the right ways or words, this is like how you got started with the Hello World, at least when I got started. And today it's kind of fancier. But as you will see, it's not only always about the fanciness. So it doesn't always have to be cloud native, distributed, containerized, microservice, whatever. But we have all the buzzwords there, so that's kind of the right way to get started. So let's dive in. Which sin is that? Who recently watched the movie Se7en? Anybody remembers? Gluttony, the overindulgence and overconsumption of anything to the point of waste, which might be add all the dependencies, which you might have seen in your own projects. It's where like, oh, we have this thing, and let's pull in one other thing, and let's have all the dependencies, which is not great for memory, disk, and network if you deploy your applications, because, well, everything is kind of fatty, and it takes a lot of time to roll it out. And then people recently were complaining that Windows 95 was 30 megabyte and Windows 10 is 4 gigabytes. Is it really 130 times as good? And do you really need that and get that out of that? And the other thing is Google Apps takes 150 megabytes just to write the keyboard. Do you really need 30 times as much data just to type on a keyboard? Who would agree with those statements? Like, this is a problem. Like, you should never do that. Okay, that's kind of a valid concern. The other thing is, people then also said, like, well, maybe there is a good reason for that. So I think the answer is still always, it depends. Because if you just take modern screens, they have a lot of pixels. So stuff gets just large because of the high density we have on our screens. So it's not just, yes, everything is wasteful. Some stuff is really wasteful. For example, is anybody using Slack? Slack is eating a lot of memory, right? That's kind of the thing that might be properly wasteful. But not everything is. For example, yes, if you have like a high definition frame buffer, that will take a lot of memory because it's just a lot of data and pixels you need to render. So it's not always that simple that you say, oh, everything is terrible and everything is bad. Okay, when we're talking about Microsoft, you might have seen this quote, 640K odd enough for anybody, which back then Bill Gates supposedly say or didn't say about using memory. Is anybody using Node and like in the NPM ecosystem? Because in NPM, the challenge is normally to build a project with fewer than 640K dependencies. Because in Node, everything is a tiny, tiny dependency. And when you're saying, well, this is ridiculous, like clearly there are not that many dependencies, take a look at this. For example, somebody made a dependency for every single emoji that is out there. So you can include one single emoji as a dependency into your application. And what I find also amazing is that you need 3 digits to version them. That it's like 1.2.1, and I'm not even sure this is the latest version anymore, and all of them are unit tested as well. and you have like the emoji is maybe 5% or so of the entire project, and the rest is just packaging and testing around emojis. So yes, you can totally do that. Also, anybody remembers LeftPad? It was some time ago, LeftPad, which was basically you had a string and you wanted to left pad it with spaces. And it's kind of very simple functionality. I think it has like 11 lines of code or so. But the person who wrote that code was for some reason angered and took away their module from NPM, which you could do back then. And that kind of broke half the NPM ecosystem because lots of very big projects had some other dependency which then referenced that left pad. And the person basically broke half of the NPM ecosystem just by taking away 11 lines of code. Which also tells us something about like just using as many dependencies as possible and not really knowing what you're doing anymore might not always be the best case. And I really like this one. Where you see the node modules really go very deep. It's like nothing goes as far as when you look at the dependency tree of your node dependencies. That one is really amazing. Okay. But enough making fun of JavaScript frameworks. By the way, do you know the JavaScript drinking game? Where you type in any word that you come up with into Google and add a .gs. And if there is a framework or a tool for that, you have to drink. That's also not that uncommon. You can really try it out. It's amazing what kind of stuff is out there. But yeah. Okay, enough making fun of the JavaScript ecosystem. We can also make fun of other ecosystems like, I don't know, Maven. And Java is where Maven uses you. It's kind of like the good old approach. But anyway, let's assume we have a lot of dependencies. And then you have like, okay, combining all the projects might be the next thing. However, at the moment, we're kind of going the opposite way, where we're trying to split up stuff into as few or as small projects as possible, right? And probably then you end up with something like this. When you're doing microservices, whatever that really means, and then everybody is just blindly following along, and it looks something like this. On the other hand, some people don't have all the fanciness, and then they want to say, we are cool too, we want to use something that's called microservices as well. And then the solution is always like, just give it a very short name, and then you can say it's micro as well in some way. So that's kind of like the excuse to do that. But why stop at microservices? Probably by now we have progressed further. So after microservices, you have nanoservices, and then Pico, Femto, Atto, Yocto. And I think Yocto is the smallest unit that you can find, or that is commonly used. So once you have reached the Yocto services, it's kind of the optimal state of services, right? It's kind of as small as it gets. It's basically probably one line of code just wrapped. And then obviously you're in the Gartner hype cycle, which is, by the way, the only thing I think that Gartner is bringing out that is true, because all the other predictions are probably not coming true, or at least historically. And you can see, yeah, you have some technology trigger where stuff gets started, and then everybody is jumping on that bandwagon, and then you have this peak of inflated expectations, and then you're falling down into that trial of disillusionment where you say, okay, this doesn't really work. And you often see this going through various cycles, like SOAP or web services had that once. NoSQL probably had that. I'm not sure where we are with microservices, if we're just still on the upward trajectory or if you're already going down again. And depending on how far you're in your environment, you're probably either just still going up or already going down. And then at some point, you probably, if the technology matures enough, you're reaching this plateau of productivity, which some of you might call legacy. Who thinks that legacy is a bad word? Okay, well, again, it always depends. Sometimes legacy just means that you have a business that works. Yes, the fancy startups that don't make any money, they don't have any legacy issues. But they also are not a good business model and they're not surviving. So sometimes legacy is kind of the sign that you have matured enough and you're kind of a working company. That's when you have legacy software as well. So I would always be careful to say, oh, legacy is all bad. Yes, it's sometimes a pain to work with, but it also shows that something is working and has been successful enough to stay around. So coming back to microservices, yes, they definitely help if you have too many people and you have too many dependencies and it doesn't scale independently and you have these problems, then microservices are great. But sometimes or oftentimes you don't really have these problems and then you're trying to solve a problem that you don't have. However, I know the grass on the other side is always greener. So you always want not to have your own problem, but you want to have some other problems because you assume trading your current problems for some new ones is better. Oftentimes, it's just a bit more exciting to have new problems. It doesn't necessarily get better. Yes, microservices get you there, but they're not necessarily always better. Will microservices solve all your problems? Obviously not. But well, you've probably seen the theme of this talk. It depends. So probably they're not the final solution for anything. Yes, if you're building something with microservices, then you're building a distributed system, which you always need to keep in mind. And then what you need to do is you need to test and deploy all of that independently. So you will need to have the right tooling and foundation to actually work efficiently with microservices. Also, they need to degrade gracefully. Speaking of degrading services, there are these 8 fallacies of distributed computing, which basically say like why distributed systems are hard and why stuff always fails in the least expected way. Who remembers that one? The fail whale. If you're older, like Twitter used to fail a lot. And by the way, I think the proper picture for that would be that one. So Twitter basically had to learn a few hard lessons. And this is a post I can highly recommend, Notes on Distributed Systems for Young Bloods. Jeff Hodges, he was an engineer at Twitter. And he describes all the painful lessons they have learned over time. So he describes that once they introduced some translation service to support Japanese better. And that translation service didn't have a rate limit. And it basically ran a denial of service against their other components. And then just because they wanted to add translations to some region for Twitter, they took down the entirety of Twitter. And well, they went through a lot of iterations and learned stuff as they went along. And they are having the proper microservices now, but they learned a lot of hard lessons. And they also implemented a lot of things to fix those. And this is a very nice post to show you why distributed systems are hard. And it's not normally because you have latency, because you can deal with latency, but because you have so many small things that can fail independently. And kind of the general state of an application is that it's always broken somewhere. And you need to still work properly even if something small is broken in your application. So that's kind of the main takeaway there. Highly recommended post. It's a few years old, but it's still very valid today. And then, since I speak German, those are the 5 nines of the German speakers, where you have like resiliency, availability, scalability, reliability. Does it even work? And none of that actually does. So those are the 9s of microservices sometimes. And then sometimes people kind of rephrase it and say, actually, please notify me when it does work, because something is always broken in your thing. Anyway, who thinks that microservices are SOA done right? If anybody still remembers SOA, by the way. No, SOA, service-oriented architecture. When I was in university, like in the 2000s, it was all the rage. It was basically the idea you build some service now, and then you basically just compose stuff. Like there will be something that has been programmed once, and then you will just be composing services together, and they will find each other automatically, and it will just magically work. Unfortunately, it didn't really work, and back then you had the SOA hype, when your boss would ask you, are we doing SOA already? And then you would think, and like, how am I getting out of this because I know it doesn't work? And then you just say like, oh, we'll just call our service SOA, and then you're doing SOA. That's kind of like the way out again. Anyway, that led kind of to the WS Death Star. Anybody remembers that? WS were all these specifications around SOA, the web service, whatever, you had transactions, security, whatever. And they were like huge, huge standards, but nobody would implement them properly. And it would slowly kill like the entire ecosystem. That's why it was called the WS Death Star. And actually, so the simple object access is just not that simple, and some people came up with another term for that. So it's actually crap. It's complicated, it's not about objects, it's RPC, so it's really crap. And that's kind of the thing that people came up with SOAP. But yeah, SOAP kind of failed, and microservices is kind of like the new generation, which tried to learn a few things from that. But some things are surprisingly similar again that you have. Speaking of crap and stuff going wrong, who's using Wireshark? Wireshark? Those are normally very bad days, right? This is when you really have no idea what is going on anymore, and then you start Wireshark to figure out what might even be going on. So sometimes there is really no way around it. If you have this huge distributed system to figure out what is going inside, then you just start Wireshark and start poking at packets and have no idea where you're going. But the nice thing is, if you like murder mysteries, that's exactly what you want, because Wireshark will give you little clues here and there, and then it's like watching a crime movie in the evening. It's like you have all the little clues, and then you try to find, we don't call it the kind of like the guy who killed somebody, but we always call it root cause analysis, to find out what is actually causing my outage and where does it happen. Anybody has an idea what this might be? No, it's not starfighters. It's that's not the idea. You have to share database in microservices. Is anybody doing that? Like share database with microservices? Okay, you don't have to admit that it's okay. That's exactly not the idea. Like generally, microservices should be independent services. And if you have or keep having this big monolithic database that everybody needs to share and everybody needs to have the same schema, then you will be in a very bad time in the long run. It's just not going to work out very well. And now some people might say, well, we'll replace our database. We'll use something else. We'll use like a stream store, something like Kafka maybe. It's maybe not exactly the same problem, but it's still going kind of the same way, that you have this very tight coupling to one system where everybody is throwing in stuff and everybody else needs to work with that. I don't think that's kind of the idea of any microservice. By the way, to kind of phrase it differently, we've spoken about legacy. Enterprise Service Bus, if anybody still remembers that, that was like the legacy and an anti-pattern a long time ago. Oftentimes, when you take your new architecture where you have Kafka and you just write ESB instead from your fancy new architecture, it's just the old thing that everybody wanted to get rid of. It's kind of like just the same thing 10 years ago. But I don't want to bash Kafka too much. It definitely has its use cases. It's just not the solution for everything. So if you have like, okay, we'll just throw in Kafka, and then we're having solved all the problems. Some patterns that you tried to avoid in the enterprise service bus, the ESB, are kind of re-emerging now with Kafka again. And that's not really where you want to go. And it's not really a progress as an industry. Okay. When to use microservices, when not to use microservices. The majority of software systems should be built as a single monolithic application. But you should properly modularize that. So you can, if needed, break it up later on. That's from Martin Fowler, who's been working a lot in that ecosystem. And he can also show you why he thinks that makes sense. And I really like this picture where you can see architecture 2005 and like 10 years later. And you can see, like 2005, probably, you understand all the technologies in there. You can keep that in your head. You know what is going on. Architecture 2016, 18, whatever, probably not so much anymore. Yes, it's much more capable, but the complexity is probably also killing you in the long run. On the other hand, if you think you want job security, this is an excellent approach for job security, because you just introduce some systems that nobody else knows in your company, and suddenly nobody can get rid of you anymore. So if that is your plan, yes, totally go for it and just add some more obscure technologies. And, well, you will probably have to suffer through your technologies, but you will be there forever. Well done. Okay. And actually, I think that's from Simon Brown. That's a graphic I really like. It shows that number of deployments units is not the only axis. You can actually see that as a two-dimensional space. So yes, you can split something up in smaller units and deploy them independently. But if you have a bad structure, that's just a distributed bad structure. This is not solving your problem. However, if you have modularity, you can have a well-modularized monolith. But you can then also split it out into smaller services, and that's actually where you want to go. You don't want to have like this big spaghetti monster and then you kind of like take out a big chunk, because it's still just spaghetti spread out all over the place. You want to properly modularize that. And then you can decide how many deployment units do I need. Do I really need microservices, or is that something we might want to add later on? Because, well, nothing is free. There is a cost to that. Yes, and then there are people who say like, okay, it's just the monolith has a bad name. We need to figure out a new cool name, and then everybody will jump on the monolith again. So if you call it Mega Platform, Uber Container, or Stereolith, this is really what you want to do. By the way, my favorite name would be Server Full, but we will get back to serverless later on. Anyway, Yes, and I also like the term microlith. Basically, you take whatever you have, you put it into a Docker container, and then it's all fancy and new. It's still kind of the same shit as before, but it's nicely packaged shit. And then suddenly it looks much more manageable, so you can totally do that. Okay. To be more productive, 2 things that you will definitely need if you want to go into the microservices ecosystem is, first, you want to aggregate your logs or centralize them. And secondly, you want to follow calls throughout your system, because otherwise you don't even know what is going on anymore. I've even seen people who say like, oh, we use tracing to actually figure out our architecture because we just keep building stuff and we don't even know what the dependencies in our system are anymore. So those are 2 things you will need. If you try to do microservices and you're still using SSH and tail, I'm not saying anybody is doing that here, but if you would still be doing that, you will also not be in for a good time, because it will be just very painful. And yeah, at some point you have like 20 SSH windows open, and then try to figure out where is that stuff even running and what is happening. And that's not where you want to go. Okay. Yes. Go faster for large teams, but probably not the right thing for small teams. So for example, Sam Newman, he's very well known in the microservice ecosystem. He has been doing a lot of talks and like thought leadership and just promoting microservices, but even he is critical of the idea of having microservices all the time. It shouldn't be like the default mode to build an application, especially for small teams. If you have more microservices than team members, maybe you're doing it wrong. Okay. And now everybody repeat after me, since we've been bashing small things so much. We are not Facebook, Google, or Amazon, so we probably don't need to use all the tools they're using, right? Maybe. Okay. Next up, which sin is that? Unfortunately, it's even written on the carpet. It's greed. For greed, I only have a single slide, which is this one. Did anybody have the joy of working with that piece of software in the past? Okay, you're more a .NET crowd, right? So count yourself lucky, because I had to do that. I still remember JBoss, at least in the good or bad old days, I'm not sure, good, bad, whatever. In those days, it would take 5 minutes for the application server to start up. Every redeploy would take 90 seconds, and after 4 or 5 redeploys, you would run into an out-of-memory exception, and you could start from the beginning. And this was pretty much when I decided, well, this is probably not the right way to do stuff. Then I went to the world of PHP for a bit, but that was also not an improvement. But at least startup times were faster. So pick your trade-offs. Like I said, the grass is always greener on the other side. Since it's just an interpreted language, you didn't have startup time problems in PHP that much. Anyway, which sin is that? Anybody remembers? Yes, sloth or laziness. We will focus on the spiritual laziness and not physical laziness. When do we want to deliver something continuously? So that's kind of the idea of anything continuous, whatever. So first off, you start with continuous integration. You build and test every single push that you have. Who is doing that? Okay. Next step would be continuous delivery. You deploy manually to production, but to development, you are automatically deploying your software. Who is doing that? Okay. And then kind of like the final step is, even to production, you deploy automatically. So once your tests, integration tests, end-to-end tests, whatever, pass, and probably somebody has done a code review, as soon as if you merge that into a specific branch, then your software will be built and deployed to production automatically. Who is doing that? Okay, that's not that many. Who thinks that is necessary to build successful software? Okay, that's more than those who are doing it, which is interesting. Maybe. I just have one thing that, this is kind of like how stuff works in production then. Basically, you're riding the train and you're laying out the tracks, and then you always hope that you're fast enough so you don't derail. That's kind of the idea of the continuous delivery then. And some people compare that to an LSD trip, because there was this very nice blog post about how does it work, or how does it feel like to be on an LSD trip. And basically, you replace a few terms, and suddenly it's a continuous delivery. And you can just have to believe in that, and then you're doing all things right. Yeah. Mind blown continuous delivery. Okay. And then this is the buzzword compliant slide. So you're trying to do all the things, and at the end, you end up at DevOps. Nobody knows what DevOps is, but everybody wants to do DevOps. Some people even try to hire a DevOps, whatever a DevOps is. But yeah, that's where everybody is trying to go. This is one thing that I found very interesting. For example, Facebook only switched to continuous delivery and deployment in 2017. So I don't know how many. I think they had more than 1 billion users. And basically, I think they had 3 front-end deployments a week, and I think every Tuesday was the back-end deployment. And if you were not there and stuff broke because of you, your name would be put up on a wall of shame. So that's how they made sure that everybody was there and was not breaking production. But Facebook got kind of quite far without rolling out software automatically. So every time somebody tells me, oh, we totally have to do that to have the competitive advantage, I'm always like, maybe, maybe not, because, well, look, Facebook didn't have to do that. They seem to be doing quite well, or have been doing quite well without that. Anyway, so stability of your deployments is also kind of an issue then, because, yeah, 60% is not that great. And then there is the Russian term for DDD, which is my favorite, davai, davai, deploy, where it's just like, okay, whatever we have, just roll it out as quickly as you can. It doesn't really matter if it works or if it doesn't work, as long as it's DDD. That's the proper DDD definition for me. The other thing is that it's deadline-driven development, where, you have a deadline the first 70% of the time or so, not much is happening, and then you squeeze in everything into the last remaining sprint, and it's always a continuous death march. Speaking of that, sometimes continuously deploying is really continuously because it keeps failing so much. And then you have continuously trying to deploy your software for a day or 2 days. That's maybe also not where you want to get. Okay, and some people always say continuous life cycle. Others feel more like it's a continuous death cycle, where it's like you're constantly on a death march to deploy your software and it's still failing and you don't want to get there. Okay, anybody using Jenkins here? Anybody liking Jenkins here? It's probably the Stockholm syndrome, right? Where you kind of made friends with your captor and then you say, oh, it's not that bad, actually, it's kind of a nice guy. I have very mixed feeling about Jenkins. I have used Jenkins a lot in the past. I don't have to maintain Jenkins at our company anymore, and I'm very glad. But my colleagues wholeheartedly agree with that you have these 3 states of Jenkins, that they're either a jerk, it's junk, or it's jank, where it's just like no good reason or nobody knows what it's really doing. So these are oftentimes the experiences people make with Jenkins. And CloudBeast, the company behind Jenkins, they also figured out that they want to change stuff now, and let's see where Jenkins can move. It's probably one of my most widely used systems, or at least on-premise the most widely system, I would assume. It's still not the most loved one. On the other hand, you always have this discussion like, do people like your product, or is anybody using your product? And you have to pick either one. Either you are hated or nobody uses you. And, well, Jenkins is clearly on one side. Anyway, one thing that you don't want people to do is break the build all the time, who has a build that has been read for more than a week? Anybody? Why are you even testing it or running Jenkins anymore then? Or your testing system? It's kind of like, if it's always read, nobody cares, and it's kind of like, maybe you can just leave it out. By the way, the one trick around that is there is this, since Volkswagen had this incident where they tried to cheat, there are plugins I've seen them for Node and PHP, where there is a Volkswagen plugin that makes your tests always pass on the CI server. So locally, your tests might fail or behave correctly, but if the system detects that you're running on the CI server, then your tests will actually always pass. This is the trick how to get your Jenkins green again, or whatever your integration testing tool is, or your build server. Wherever you want to do that, install the Volkswagen plugin, and it will fix your stuff for you. The other thing is, if you don't have tests, you don't have failing tests. That's kind of another good way to work around that, which also saves time, because so many people say, oh, we don't have time for tests. It's like, sure, sure this will work out great in the long run. Anyway, something I think that's still a good idea or that you should do is separate code and configuration, because nothing is more annoying than if you have hard-coded something and you change some configuration, I don't know, your database URL changes or something in your setup changes and then you have to re-roll your entire application. You don't want to do that. Keep your configuration out of your code. It should still be versioned or automated in some fashion, but don't couple the configuration to your code too much. I've kind of had bad experiences with that. And the other thing is, please don't commit your secrets into any version control. Did anybody get ransomed because of that? Or did anybody's instances on AWS start mining Bitcoins? Anybody? Because that is kind of common. The common thing how this happens is you have an internal project and you just commit your AWS credentials because it's easy and you need access to, I don't know, the S3 API or whatever. So you just commit your credentials and then the project sits there and 2 years later, some colleague decides, well, this might actually be very useful software. And then they decide to open source that. And then they just switch the flag on GitHub and make the repository open. And then the bad guys are automatically scanning GitHub with a regular expression to figure out, oh, this looks like an AWS access key. And as soon as they have that, they will start mining Bitcoins for you, which is totally inefficient because probably you invest $1,000 to get out $10 in Bitcoins. But if it's not your money, it's still a win. So they will be doing that. By the way, AWS and GitHub started to monitor GitHub as well for credentials. But then it's just a race who is quicker to find your credentials, either the good guys to block your keys or the bad guys to start mining Bitcoins. And you don't really want to rely on that race, I guess. Okay, which sin is that? Lust, the intense and uncontrolled desire for something. And in software, this normally means always use the hottest shit. Probably a lot of us here are guilty of that. It's like, do I really need that for the project? Does it make the project better? No, but I still want to use some specific technology. I don't want to bash any technology too much. No, maybe I do. If you call something high latency, low throughput, append-only database, nobody would be very excited for it. If you call it blockchain, then everybody is, whoa, this is so revolutionary. This will save us all. The other way to see that is databases are garbage in, garbage out. Blockchain is garbage in, garbage carved in stone. Like you will never get rid of that, which is also a nice way to see that. But let's switch away from blockchain. Let's do something else. Who's using Docker? Who's using Docker in production? All the hands going down. No, not all of them, but quite a lot. Yeah. The thing is, if you release like once a quarter, is the deployment process really your main concern? But I get that Docker makes sense for some. For example, yeah. The other thing that you run into frequently is Docker containers are supposed to be small and have one process. However, if your deployment unit is 700 megabyte, then you know why Docker has the whale as a mascot, right? And I think that the proper whale is, or the proper logo is, by the way, this one. And you're all the little Nemo fish that will get eaten by Docker at some point. Anyway, so where Docker is kind of great is before it worked only on your machine. Who had a colleague who had that? Because I did in the past, and I had one colleague who always had some piece of code that was only working on his machine back then. And at some point, we just told him, well, back up your email, your laptop is going to production now, because this is the only place where your software is working. He didn't like that much, and then you can try to change it with containers. Maybe it's just like in my container it works and in no other container. That's some other thing that you might run into then. So this is basically what you get when you use containers. You know, this was when Nemo tried to escape from the fish tank, and that's their way of escape. So yes, it's nicely packaged, but it's probably not solving your entire problem. Like this doesn't solve your architecture, for example, because yes, nice little packages, but this is not the end goal that you want to reach. Some people always say like, oh, containers are so elegant because it's all containers and you don't need to care about anything else. It's the same thing when people say, oh, it's all tires. Like all the tires are burning, but it's still all tires and it's kind of all the same. Which, yes, this is the more impressive view of that. This is sometimes what you have when you have like, oh, it's all Docker. Anyway, containers everywhere. This is kind of the common theme I see, that people don't really know what they're doing or why they're doing it, but they want to containerize everything because they just hope the grass is greener in the container land. And then people say containers are just a process. Who is agreeing with that? Containers are just a process. Nobody. One. Okay. Yeah, the thing is, yes, it's just a process, but suddenly the process has its own network and storage layer. And those behave probably differently than what you are expecting. And they will depend on the host operating system. And something we see often, like we have official Docker images, and at least 50% of the questions we get for the Docker images are actual Docker questions. So basically, everybody who's providing official Docker images is most of the time just doing Docker support. And we are not too fond of that, actually. Anyway, at some point you maybe say like that you're too old for that stuff and you don't like containers that much. Well, unfortunately, there's no way around them. However, they won't fix your architecture. Even if you just containerize everything, it's still like probably crap in containers, but it might still be the same architectural crap that you had before. This is one of my favorite pictures for that. You see, all the containers are doing fine independently, but your architecture or your system in total is probably not doing so well, right? But the containers themselves, they're okay. And the other thing is, you can even have security issues in containers. So a while ago, there was glibc, which had a security issue, and then you had to re-roll all your images back then. If you're using Alpine and say like, oh yeah, big bad glibc, well, Alpine recently had a security issue where you had to re-roll all your Alpine images. So it doesn't solve all your problems that you had before. Security is still a concern that you need to take care of, even with containers. One other thing, that was a gem I found recently, if you do docker compose down v, it removes all volumes. If you just want to print the version and you switch around the v, it prints the version, which is maybe unexpected depending on what you wanted. If you just wanted to print the version and suddenly you kill all the volumes, it's not going to be a good day for you. The other thing is, I sometimes struggle to see, like, I'm coming more from the JVM world, I sometimes struggle to see why we need these containers, because suddenly our dependencies are much larger. So for example, for our official images, previously we had our software, which was a dependency. Now we suddenly have the JVM as a dependency, and we also have the base system as a dependency. So it's not just when we release a new piece of software, we need to re-release the container, but every time there is a security issue in one of the upstream projects, like the JVM or the base image, we also have to re-release that. And we also have to do that for all the past releases in theory. So any supported version, we will need to re-release. And it's kind of like a big process to add because your dependency tree is suddenly much larger. Any ideas what this is? The containerized legacy application. Yes, you can put COBOL into a container, but it's still COBOL in the end. This will not solve the COBOL issue for you. And then you can kind of combine microservices and containers, and then you have a cargo cult. Not sure everybody is using cargo cult on a frequent basis. I always think that Dilbert is explaining it best. So their explanation is they have a big, successful company, and they're using technology X, and then if you're using technology X as well, you will be just as successful, right? It's kind of the logical choice, which some people seem to really think. The problem with cargo cult is you basically repeat the motion somebody is doing, but you don't really know why they're doing something. And to put it another way, on more technical terms, is who's using Kubernetes because Google is using Kubernetes? Is anybody doing that? Good, because Google is also writing their own file system. And I hope nobody here is trying to write their own file system. Maybe. I once had a colleague who had this not invented here syndrome, and he once started to write his own encoding. So there are cases for that as well, but that's probably not the thing how you should approach that. Just because big company X is doing something doesn't mean you should blindly follow them and just use the same approach. The thing is, and this is actually a very good Twitter thread if you are trying to work with Kubernetes, and it explains all the things that they tried to build with plain Kubernetes and which didn't really work out for them. So stuff like multiple environments were a pain, single sign-on, security issues. it's a very interesting thread about all the things that you don't really see when you use Kubernetes, because at first it's shiny and easy to use. But the deeper you go, once you scratch the surface and you need all the finer details and integrations, stuff can get much more painful. And then, especially with Kubernetes, it's not hybris anymore, it's kubris, where you believe that Kubernetes can do really everything that you have. Or some people also call it the Frankenates, where whatever you have, you just put it into Kubernetes and that will fix all your architecture things. Unfortunately, no, doesn't work like that. Okay. And then people always believe like, oh, we need speed. At least it's fast. Like whatever we do, we need to develop our software very fast. And then you end up with something like this, where you go very fast, and you can see at the bottom right corner, you're stuck kind of in your tech debt of going fast, and then your bugs are drowning you. Sometimes it feels like, as an industry, we have focused very much on this going fast, and software needs to be deployed like today, and at best like this hour or even within 10 minutes. But does it really solve all the business needs that you have? And is that speed really improving your process? Maybe it is, maybe also it is not. Okay. Any guesses what might be wrong here? So assume you have a stateful production service and you're trying to start it like, this is an Elasticsearch image, but it doesn't really matter. And this will not work anymore for good reasons, by the way. Anything that you think might be an issue here or cause an issue later on, maybe? Do I have a version defined for my image? No. Basically, the version would be at the very end. So we're using our own Docker registry, but we have not defined a version for Elasticsearch. So basically, what we would get by default is latest. The problem is, if you start a cluster with 3 nodes today and use latest, you will get 6.4.1. If you, in half a year, you add 2 more nodes and with latest as well, you will get a new major version. And probably you will kill your entire cluster by that. That's why stuff like this, yes, it's very fast if you don't have to define the version, and latest is very convenient, but there is a good reason why you should not use latest for, at least for stateful services. Because if you add more capacity later on, you might get a totally different version, and you might break your cluster. I call this the zombies, the ideas that should have been killed a long time ago, but they kind of keep shambling along. Because I think we're getting every 3 months or so on our GitHub issue tracker, we get somebody opens an issue and says, we want to use latest. And then there are various arguments why they want latest, and we're always like, we don't think this is a good idea. This might be very convenient for development, but for production, you really don't want that. And we consider our images production ready, so you don't have latest. And we're sorry, but you will need to define the version explicitly. The other thing that we see, especially with Docker quite frequently, is, can you run Elasticsearch as root? Anybody guesses yes? Anybody guesses no? No, we cannot do that. A, because we think it's a bad practice, and B, because we just stop you from doing that. So basically, we have a check. If you try to start your processes or Elasticsearch as root, we do a system exit. And the only way to get around that would be to take the source code, comment out that line, and compile it yourself afterwards. However, with Docker, we have met people who tell us that for us, it's best practice to run every process in a container as root, because it's kind of containerized into the application anyway. That's something we also strongly disagree with. I always call these the cockroaches. Yeah, when you were running a service on your host, nobody wanted to run it as root because everybody understood that this was a bad idea. And now kind of with containers, the idea has come back that this might make sense because, well, it's containerized. And these are the cockroaches that kind of reappear after some time. We're working on getting rid of the idea again. Let's hope it doesn't reappear after some time. Okay. In the Java ecosystem, do you even need containers if you can make the fat jar file, which contains all the dependency, whereas the war file might not have all of them. So one of the things that some people always say is make jar, not war. So make the big fat jar, which contains all your dependencies, and then get rid of the application server. Okay. Who likes writing YAML? Who is using, or who is writing a lot of YAML? There's probably a lot more. I think that's another kind of Stockholm Syndrome thing. I think this is a very good description of how YAML works. Where, the indentation in YAML is kind of critical. And it's sometimes very hard to see, like, how many spaces do you have, and is it all properly indented? And this is basically what your software development can get to. And I know that, for example, XML is very out of fashion, but XML had kind of advantages. It was hard for humans to read, but you had something like a schema, and you could very easily validate that something is working the way, or structured the way it should be. Whereas with YAML, it's pretty much like, yeah, you write a YAML file, you try to start your application, and then you see what happens. And normally it barfs with some weird error, and then you figure out, oh, I missed 2 spaces here, or I did something else wrong in my YAML. I always have the feeling that, yes, we're writing a lot of YAML, but in the end, it's maybe not the best format for everything that we do. Like, if you have a 10-line YAML file, that's fine. If you have a 100 or 200-line YAML file, maybe it's not so much fun anymore, especially if it's very deeply nested. That's just a thought that I keep having. Anyway, serverless. Who's using serverless? Anybody serverless? Function as a service, whatever. Yeah. Serverless, there's always this discussion, are there servers in serverless? Yes, of course there are, but people still call it serverless. It might look something like this. You don't have to care like for all the details. You just see you stack it very deeply, and you just care about your car, or like all the rest that is happening there. You don't really need to worry about anymore. And sometimes people kind of not realize anymore that stuff is really running on hardware. That's kind of the birds and bee discussion for software developers or DevOps engineers to do that. Okay. Yes. We acknowledge that serverless has servers. Move on to the architecture. Okay. And sometimes services cry out because everything is serverless now. And the new architecture style is, we had serverless, now we had codeless, and next up is architectureless. So you get rid of everything that you don't need in your process, by the way. Okay. And then some people are saying like, oh, this is like the new stored procedure, right? In 2025, 30% of all the technical debt, or 30% of the technical debt will be serverless. Some people say, oh, it's just platform as a service reborn, which was all the rage when I was at university. However, it has some new attributes. So for example, you can start it up very quickly, like in a few milliseconds normally, and then you run it for half a second, and you're only billed for half a second. That's something that you couldn't do before. Platform as a service was very convenient as a wrapper, but it was very hard to run it as the general model. Okay, and yeah, any cloud provider that tells you they're using a hybrid strategy is probably just failing at cloud. That's my personal opinion as well. Okay, next up, pride. Thinking that you're better. Who here would identify as dev or development? Who here would identify as ops? Who is DevOps or somewhere in the middle? Okay. Well, sometimes dev is saying like, we'll just implement this new shiny thing. Good luck with that. Enjoy whatever you're doing. And then you have an ops team, you have a DevOps team, and then you have a dev team. And it might look something like this. And then you can combine everything together as dev, ops, ops. That's kind of like your whole architecture. Sometimes it looks something like this. This is the enterprise DevOps, where you have Jira, which is on fire as always, and then everybody trying to put out the fire from various ends. The one thing I strongly believe in is that DevOps is not a technology. And it's also not a person you hire. It's more the approach of how you do stuff. And if you do say like, oh, we do DevOps, but we don't do all the stand-up CI code or any of that other hipster stuff, you're not doing DevOps. You can call it DevOps, but it's not kind of the idea of what you want to do. And what also doesn't work is creating a DevOps team, because DevOps is kind of breaking down the walls between the different people involved in the software process. If you have a dedicated DevOps team, that's kind of like counter the idea. Yeah, and then to err is human, to roll it out to all the servers, that is automation, and that is then DevOps. That's always a good one. And the other thing is, yes, putting horrors into containers and then talking about Kubernetes at conferences. I'm sure we have a Kubernetes talk here as well somewhere. This is kind of like going in the same direction. Anyway, we're kind of running short on time. I skipped like 2 more sins. By the way, when something is down, this is what ops is actually doing to recover your service. Basically, you're giving your server a pat on the back, and then it's kind of like, oh, I'm a good server, I'm up again. Anyway, to wrap up, developers are like werewolves. Like, there is no silver bullet. Anybody who tells you that this is the final solution and this is how to do everything is probably not going to work out that way. The other thing I really liked is thinking back 5 years, which beliefs did you hold strongly? Like things that you believed that were absolutely true and you had to do, and this was the right and only way to do something. And how many of those beliefs are still true today? Probably not that many. Don't believe too strongly in something today because you might have to reconsider in the future. And this is kind of the main takeaway of this talk. Like, yes, we have all these fancy tools and we strongly believe that whatever technology X is solving our problems, but it might not always be the case. And maybe I'm just getting old and grumpy, but I have a hard time believing into the kind of promises every new technology and every new generation of technology is bringing out. Those were our sins. If you ask, like, what did you learn today? I guess the answer is it depends, and just to ask the questions. Any confessions now? Anything you're doing wrong? Any general questions? Yes. Okay, the configuration management didn't change since 1990. You mean that it should be automated and should be... Well, in the 90s, you probably used a very different versioning control system than... I think we would need to have a very deep discussion about that, because I think Git and distributed version control changed version control quite strongly. I think we're out of time. Yes, but we can continue the discussion afterwards. Yes, thank you.